We start off with methods in algebra. Algebra, the foundation, I guess, of all good maths, which allows us to solve problems dealing with the unknown. Right, so the first thing we probably learn in algebra is this little thing. Like terms can be added or subtracted, unlike terms cannot. Simple little idea, really. See, we don't get caught up with whether we know something or not. We'll call it X, we'll call it Y, we'll call it Z, we'll call it whatever we like. And the fact that I don't know what it is doesn't stop me from doing the maths, because I know that, yeah, I don't know what X is, but I know if I got an X here and I got an X here, I got two of them. So 2X, so that's the whole basis of it. I don't think I bothered with any examples for that one. I think we're okay. Then we have some laws which allows us to manipulate the algebra. The old, yes, if we multiply, we add the powers. If we divide, we subtract the powers. When it's in parentheses, that's when we multiply the powers. And of course, the lie that we always say, anything to the power of 0 is, which is of course a lie, isn't it? What, is it true? Anything to the power of 0 is 1? You happy with that? Huh? What's 0 to the power of 0? Is it? Really? Put it in the calculator. Who's got a calculator? Error. It's not 1. 0 to the power of 0 is not 1. Okay? I know, isn't that cool? Okay? So yes, it's a convenient lie we've been telling you, because it is the only number it falls down on, but everything else it'll work. What do they actually mean, these indices? Again, when we start off with maths, we usually start off with really simplistic explanations which allow us to do basic situations, yeah? And same with indices. We simply said, it's the number of times you multiply it by itself. That might have been how it got introduced to you back in maybe even primary school, whenever you first saw powers. And yeah, that's a okay explanation for what you have to do. But then we introduced the idea of fractional indices. Yeah, so you got power of a half. How many times do you multiply it by itself? Half. Hey, how do you multiply it half times? And then there was negative numbers too. We could add those in the powers. I multiply it by itself -3 times. What, does it mean I'm going that way instead of that way? So what do they actually mean? This is how I think about it. Positive number to me says top of the fraction. I'm on the top of the fraction. Negative means I'm on the bottom of the fraction. Okay? I suppose it would be more correct to say positive means I'm on this side of the fraction, negative means I'm on the other side of the fraction, because if I had a negative indice on the bottom of a fraction, then it actually would go to the top of the fraction. It would swap sides. Okay? So it's like a little instruction. Where do I put these things? And then fractional powers, A over B, what does that mean? Well, the A, the top tells me the actual power, that good old, how many times do I multiply it by itself? The bottom is the root. Now when you had a whole number, you had like 2 over 1, well you didn't write it as 2 over 1, you just wrote it as 2. But technically, it is actually the first root of something squared, for instance. What's the first root? I mean, the first root is just itself. So we don't normally talk about the first root, we talk about the second root, square root, and so on and so on and so on. But that's really what it's saying. So it becomes the bth root, whatever b is, the bth root of x to the power of a. The order you do it in doesn't matter. Some people prefer to go, hang on, I'll find the bth root of x first, and then raise that to the power of a. When you're dealing with numbers, that's probably good, because when you find the root, it makes the number smaller. It's easier to raise the smaller number to a power than get this really big number and find the root. So x to the -3 simply says, I'm on the bottom of the fraction. 1 on x cubed, it's done. Once you've done the instruction, the negative, you don't need it anymore. Top of the fraction goes 1, because as we know in algebra, we don't normally write the coefficient of 1 when it's there, but it's actually there. And 1 is to the power of 1, positive power, bang, it's on the top of the fraction. And so if I've got a mixture, okay, the 5's positive, it's on the top of the fraction, the b is negative, it's on the bottom of the fraction. Bang, sorted. And then we get crazy. We love to do this in maths, don't we? We love to make questions look harder. By, let's put more in there. And people go, so many different terms. But you just treat it individually. In fact, they've done some of it already. Look, 3/4. They've already decided for me the 3's on the top, the 4's on the bottom. But then the x is negative, it goes to the bottom. The a is positive, it goes on top. So it's just all the same rule. We just keep using it. Quarter, bottom tells me the root, top tells me the power. 4th root of x. 2/3. Oh, it's cube root of y squared. When I'm dealing with algebra, I tend to go that way rather than cube root of y all squared. I just think it looks neater. Personal preference, doesn't matter. This one's interesting though. Square root of x cubed. Yes, it is. And that's how a mere mortal might leave the answer. But as we know with surds, we should always simplify surds. And the square root of x cubed can be simplified. Not immediately obvious. When we're dealing with numbers, it's obvious when you simplify a surd. But if you remember the idea behind it, what you're doing is looking for a perfect square that goes into that number. Well, there is a perfect square that goes into x cubed. It's x squared. So I could look at that and think, it's the square root of x squared times x. But the square root of x squared is x. So that becomes x root x. There's the simplified surd. There's a real easy way to spot it. 3/2 is an improper fraction. So if it's an improper fraction, that surd can be simplified. So it's the improper fractions that will be simplified. Because you see 3/2, but I think 1.5. I don't write 1.5 down. That's bad mathematics, bad notation. But in my head, I'm saying 1.5. It's x to the power of 1, x, times x to the power of 1/2. X root x. Yeah. So actually, they're very easy to simplify. You just look at the improper fraction, it tells you straight away how it simplifies. I don't know that I've ever really seen this, but okay, say you did get something to the power of 27 on 4. 27 on 4, it's a mixed numeral. What is that? 4 goes into 27 6 times, doesn't it? So that's 6 3/4. So m to the power of 6 and m to the power of 3/4. Power of 3/4, top tells me the power, 3, bottom tells me the root, 4, 4th root of m cubed. There it is. Something which would have looked like a really horrible question. Actually very easy when you think about what all the things mean. Nah, not a problem. It's where these mere mortals are going. Oh, geez. But not us. First of all, we draw in a
vinculum.
Vinculum. Very good. It is a vinculum. That is the name for a fraction bar. Vinculum. Okay, a half. One goes on top, but I'm not going to put it there because I know it's going to end up being the coefficient of the algebra. 2 goes on the bottom. End of the cell, well, that goes to the bottom. P to the 500, you're going on top. Q to the minus 1 on 28's on the bottom. 1 on 28, well, 28th root. 28th root of Q. Ooh, C to the 7 on 6. 7 on 6, it's an improper fraction. 7 on 6, 1 and 1, 6. It's going to the top of the fraction. C times the 6th root of C. And then we have R to the power of 69. Because it's got nice rotational symmetry about that number. 69, you grab it, you turn it around. It's still the same number. Great number. There we go. Fractions to a negative power. Quickest way of doing it is to turn it upside down. Because remember that negative instruction is saying I'm actually on the other side. And using my index laws, I could think of that as 2/3 to the power of -1 squared. So it's 2/3 to the -1, which is saying, hey, I'm actually on the other side. So the 3 goes to the top, the 2 goes to the bottom, and I'm just squaring it. So that's always the quickest way of doing fractions to a negative power. All right. 1a. Oh, asterisk, that must come from the extension. 6a